from here and there channel. Simple solution to Boeing 737 MAX problem. Until the publication of this video, this aircraft grounded for almost a year, without a solution. This plane suffered 2 fatal crashes, killed the crews and all passengers. The solution of the problem is very simple, is to rotate the engine downward from 1 to 2 degrees only, depending on the amount of imbalance in the plane, which is known to the manufacturer. This angle of rotation is very small, barely noticed by the naked eyes. However, it achieves the plane's physical balance, in order to avoid nose lifting at high thrust, which is the main problem of the plane, without causing any reduction in the forward thrust, as will be explained in the analysis at the end of this video, nor causing a noticeable reduction in the lifting forces of the plane. Abstract. The Boeing 737 MAX is the newest and the best-selling plane in Boeing family, with more than 5,000 orders. Upgraded urgently from the older 737NG model, in a response to the Airbus A320neo. The upgrade is to use a more efficient engine, but bigger and heavier than the replaced one, without redesigning the aircraft, seemingly a cut in time and money. The problem: because the added engine is larger than the old one, and because the wings of the plane are close to the ground, low, due to the low body design, which does not provide room for the new engine to be installed. The engineers of the company solved that by moving the engine forward and lifting it up a little. This solution enabled the installation of the 2 engines, but it disturbed the plane's balance, which causes the nose of the plane to be raised, especially when using the maximum thrust, which often occurs during takeoff. The company's solution to the problem. The company intends to solve the problem through using a computer program, software, called MCAS, rather than providing physical balance, because it requires a redesign of the aircraft. In other words, building an entirely new plane. The problem created by the MCAS. This MCAS system has the priority on the pilots. If the only one sensor outside the plane detected that the angle of the plane is high, the system is activated and lower the nose, and prevent stalling. The problem happens if there is a malfunction in the sensor, which leads to the transmission of wrong information to the system. It pushes the plane nose down and increases the power of the engines. This system will reactivate it each time the pilot corrects the plane's position. In one of the 2 aircraft's crashes, the pilot tried to correct the position of the plane more than 20 times before the crash. The solution proposed by the company to avoid the problem is by modifying the software so that it is activated for one time only, and does not resume working after the pilot corrects the plane position. However, the solution did not acquire the approval of the U.S. Federal Aviation Administration. It also does not achieve the plane's physical balance. The reasons for the plane imbalance. 1. Because the diameter of the engine is greater than the previous engine, and although the engine installed slightly higher, the center of the engine seems not raised from the previous one, and because the new engine had more thrust, this led to the generation of a bigger moment that raises the front of the plane. The more thrust provided by the engines, the higher turning moment produced. 2. Turbine nacelles generates additional lifting forces, because they act as small ailerons, where airflow pushes them up. And because these engines are larger than old ones, these forces increased, as well as the distance to the plane's center of gravity increased because the engines have been relocated forward. The turning moments generated by the uplifting forces increased. These turning moments lifts the nose up. These moments increases as the speed increases. Analysis of the proposed solution. The figure shows the forces acting on the plane. These forces are calculated by the equations shown. Equation 1 will be used to compare the effect of changing the engine angle on the lifting forces, between 0, that is, there is no rotation, and the amounts, 1 and 2 degrees. The comparison will take place only on the first term, which represents the lifting force resulting from the thrust, because there is no change in the wing design, and the wing's lift is a function of the speed, not the thrust. Therefore, there is no change in the wing's lift. While we use equation 2 to compare the effect on the forward force, only the first term is used, for the same reasons mentioned. Thus, taking the first term for different takeoff angles, between 10 and 15 degrees, minus the adjustment amount by 1 and 2 degrees, divided by the same term using the angles before the adjustment. As in the two equations above. The results are in this table. Note that a slight change in the angle of the engine has reduced the force that raised the nose of the plane by 8% to 16%, while causing a slight increase in the forward force of the plane by 0.4% to 0.7%. As mentioned before, that this change includes the first terms in equations 1 and 2 only, and it has nothing to do with the lifting capacity of the wings, that is, the second terms in the two mentioned equations, as the wing lifting force is a function of the plane's speed. That's it, the plane is balanced again. Wait for more videos from this channel. From here and their channel.